All right. Primarily, we're going to talk about, again, the pipe heating cables and the gutter heating cables. But along with that, we're going to talk about a little outside wiring also, since that can get involved. First off, let's start with a little common sense. Pipe has water in it. Gutters have water in it. What is the first thing we're going to want to install if we're using this equipment? Anybody got a good idea? Well, a ground is one thing, yes. GFIs, thank you. By the Chicago Electric Code and the National Electric Code, anytime you're using these kind of cables, you must use GFIs. Whether it be a standard plug-in GFI, an add-on GFI to a normal circuit, or if you're really getting serious, a GFI breaker to protect the whole circuit. Anytime you're using a GFI, they must have a balanced circuit. So if you're going to put in a GFI on a new circuit, you want to run a new hot and a new neutral, all the way from the breaker box to the GFI. In Chicago, if we're using steel pipe, that is your ground. You don't have to run a separate ground wire. If in fact we're running underground with plastic pipe, for whatever reason, you have to bring in a ground wire. So you'd be running 3 wires. If in fact you are running underground and you're using underground direct burial cable, that has a separate ground wire already in it. So you'll have 2 wires, your hot and your neutral, plus a bare ground wire in this. Talking about the underground pipe for just a second, and if you were going to run your wiring to your garage and then your heating cables at your garage, there are 3 things you can put underground. Heavy wall pipe, which normally comes with threads. This is not plumbing pipe now, this is heavy wall conduit. Underground PVC, you can tell it by its gray color. It's not the white or tan plumbing pipe. It's designed for direct burial. It's extreme heavy wall, and it's so it won't crack. And then, of course, we have direct burial cable. All right, let's get with the other requirement. Somebody mentioned ground here. If we are talking about gutters, in Chicago, your gutter system must be grounded. Just because your gutters in a lot of cases run into the ground doesn't mean they're grounded. They usually run into a clay pipe, or in some cases now PVC pipe. None of those are conductors, so in effect your gutter system is not grounded. By the Chicago Electric Code, they must be securely, mechanically, and electrically grounded. How do we do that? There's various ways. We can get to the nearest electric pipe or water pipe. Screw a fitting into the gutter system and then clamp onto the pipe, and your gutter system is in effect grounded. If we're talking about pipe, our pipe systems are naturally grounded. Our electrical system grounds to the water pipes. The water pipes eventually lead underground. You have to make sure your meter is jumped, though, from where it feeds from the street and where it goes to your house. So your water pipes are naturally grounded. The different types of cables. In terms of the easy heat cables, they come in many different lengths. They are relatively inexpensive. They're basically what I would call plug and play. You can plug them in, wrap them around the pipe and or down the gutter, and you're done. They have thermostatic controls where they can plug in, so they're temperature regulated. Although these cables only run at one temperature, on and off, they can be temperature regulated by a thermostat, a plug-in thermostat. The Raychem cables are a little tougher to work with, a lot more expensive, but they do have one advantage. They can be custom cut to whatever configuration you want and combined together. So you can combine dual gutter systems, triple gutter systems, whatever. Their advantage is that they are self-regulating. This is a product out of what essentially was our space race many years ago. I will show you when I start working on the cable exactly what it is, but it's a conductive thermoplastic, and the colder the temperature gets, the more this conducts electricity and the warmer the cable will get. So as the temperature drops, this cable starts heating up. Conversely, it can almost shut itself off, not quite, but almost, when it gets warm out. So you always want some sort of shut off on this cable to begin with. In fact, any of these cables you don't want to leave on all the time, whether it's a pipe heating cable or a gutter heating cable. They really only have to be on when it's super cold out. Now, if you have a crawl space during the winter and you're not going to get in there for your pipe, yeah, you'll probably want to leave your pipe cable on all the time, unless you can get to the control outside of the crawl space somewhere. But other than that, especially a gutter heating cable, if it's not snowing out and there's no melt going down your gutters, I don't care how cold it is, the cable doesn't have to be on. If it's snowing out, I'd recommend turning the cables on. But if it's not snowing and most of the snow is off your roof and already melted, there's no need for this cable to be on. It's just energy conservation. Even though it's self-regulating, if it's cold out, it's still going to heat up, and for no reason. It's there just to melt the ice and the snow, and then it's done. You can turn it off. Any questions so far? Okay, a little on outdoor wiring. I did a little bit of the underground. If in fact, and here we'll diverge just a little touch, you can also heat up fountains, bird baths, and things like that. If you're going to run extension cords for whatever reason in your backyard or even in your front yard for whatever heating you'll want to do, or even your holiday lighting, I would recommend that you use some sort of seal where you're going to plug things together. This has not only a mechanical aspect to it where it can twist and hold the plugs together. There is in fact a moisture-proof seal in here so that when you put the male and female plugs together, it seals that connection, and then mechanically this twists and mechanically seals it so it can't pull apart, and gives you in effect a moisture-proof, I didn't say waterproof, but I said at least a moisture-proof connection. Anytime you're going to run an extension cord, whether it be up to your roof or through your yard is easy. You want to keep this off the ground and or off the roof where it's going to get snow directly on it and then melt directly on it. In the yard, it's easy. All you have to do is put a stake into the ground. Your wire then would, get up above the snow line. Just wire tie it, and you're done. Also comes in handy for killing vampires occasionally too. On the roof, I would recommend if you're going to use an extension cord to plug the cables in and then run to an outlet somewhere, maybe down on the stairwell or whatever. Again, try and keep this off the roof itself. Maybe attach it to one of the vent pipes somehow and just keep it up off the roof where it doesn't get, inundated on snow and water. All right. Again, the Easy Heat cable, the main advantage is it comes in a lot of different lengths, from 7 foot all the way to 100 feet, depending on what you want to do. Very easy to work with, plug and play, but you can't cut into it. You can't do anything fancy with it. So now we'll switch over to the Raychem product and how to work with that. I'm not going to go into discussing how you're going to calculate the length. That's going to be up to you. We do have some handouts here if in fact we wanted to pass these out on how to work with the cable. And I'll pass these around. Please see if I can get these stapled sheets back. These have some of the calculation figures in them on how to find out the lengths you need. So in fact, this instruction sheet comes with the product itself, whether it's in the box or in the packet. So we can.
After 200 feet of cable, would you recommend another circuit?
You'll notice when you look at the sheet that the longest they recommend for 120 volt cable is 150 feet. The longest they recommend for the 240 volt cable is in fact 200 feet. So over 200 feet, by their definition, they want you to run a separate circuit. Here's an example of your different cables, whether it be the pipe heating cables or the gutter heating cables. Wherever you buy the product, just be aware, because I've had some salesmen out there unknowingly recommend Winter Guard Plus for gutters. That's a no-no. It's anytime you're dealing with gutters, it's Winter Guard Wet. It has the exterior seal over the ground casing. This is strictly non-moisture oriented pipe heating cable. Can you use the Winter Guard Wet to run pipes, to heat pipes up? Yes, you can. You can go back the other way. Okay, you can use this product, but it's much more expensive and harder to work with, so why use it to heat a pipe up?
The Raychem, I was just wondering if you can use the Raychem in a gutter for a flat roof to just lay it in there?
Yes.
Okay, because it just shows it on the
Yes, absolutely. That's exactly what it's for, okay? Although you can see, they're doing a pitched roof and whatnot. Basically, Monday afternoon, Monday evening, I finished an installation on a flat roof, all right? And it ran on the roof since they had scuppers, they didn't have gutters, okay? And then down to scuppers. In terms of installation, each gutter was 27 feet high. run 4 feet into the ground, another 40 feet between the scuppers and where my connection was, and then from the roof up to that connection was about 4 feet. So you add all that together, I ended up with about 107 feet of cable that I needed.
On the black Raychem cable, I seen that there was a couple of chips on the installation. Would that affect the operation of the line?
When you say a couple of chips,
When they
is
pulled it,
this old cable?
No, it's a new one. When they installed it, they pulled it across the gutter sharp edges, and she cut.
It probably won't affect it. I'll show you why. But in terms of ultimate reliability, I would have taped those a little bit just to make sure with a good electric tape.
Okay.
Just to keep water out of the grounding system.
Right.
But yeah, I would definitely at some point have run tape over that just to make sure. This stuff is extremely tough, and I'm surprised it cut through. Did it actually cut through and show the braid, or was just?
Show the braid.
Okay.
The chip when he was pulling.
Yeah. See, when you're doing something around sharp edges, you need somebody to feed it carefully.
Right, exactly.
And somebody to pull it. Don't just yank it like normal wire.
Right.
In terms of working with the wire, this is a little easier. If you look out your little handout there, the gutter heating cable is fairly, or the pipe heating cable is fairly easy to work with, especially putting an end on it. All you're going to end up doing is pushing this back, get a little of the, protective tape off. Like that. The end, all it is a gel-filled end. All you're going to do is push it on the end here. Hold it for about 10 or 15 seconds until it sets up. If you just push it on and let go, it may try and feed itself off due to the gel that's inside. So all you're going to do is hold it until that gel starts sealing around it. 10-15 seconds, that's all you need. And then all they recommend is taking a piece of the tape that they actually very nicely furnish you. If we can get it off here. And then the only reason they recommend this, because the braid starts to fray a little bit. So they just recommend taking the tape just right above that end and just wrap it around the braid just to protect the braid. That's all it is. And the end's here, and you're done putting the end on. Relatively simple. This gets a little more involved. Okay. For the end, it's a very similar installation. What we do is take and cut a little bit of the outer cover off. Like that. Now, what they recommend on this is all that braid gets cut off. So all you're going to do is take your cutters and cut this stainless steel braid off. The reason they do this, instead of just sticking the end on, is because this braid, in fact, is a ground and will be grounded, and they don't want any stray wires getting to the conductors.
You have a call on line 2. Locks, line 2.
So now that the end is prepared, All you're going to do again is take that end, as it shows on the list of things that is in this packet, by the way. Everything you see there is in here, including the instruction sheets. And you're just going to push this end on. The end's about 1.5 inches. It's actually a little longer than 1.5 inches. I've cleaned about 1 inch, so there's no way that a stray braid is going to get near the conductors. All right? And it's done. Relatively simple. Now we get to the power connection, which is going to be very similar, except depending on how long you need your leads and if you're going to feed into a box somehow, okay, or you're going to combine cables. If you're going to run a T connection, you're actually bringing 3 cables together. Okay, let's see what we got here. So, depending on how long I need it, again, I cut my cable, or cut the outside sheath. Peel it back. This is fun at night, by the way. Now here's the difference. Now you still want, wherever you're going to connect, whether it is connecting cables together or going into a box or going into a power connector. By the way, you can, connect direct into basically a GFI module that turns the Raychem into a plug and play. You want to save this ground. And here's where it gets a little difficult. You have to sort of move it up. And then sort of work it into a hole. Excuse me if I take a little time here, but this is what you'll be doing. Okay, so it does take a little time, just to let you know that it's not the easiest stuff in the world to work with, but it's workable. Get it bent a little bit. And then you sort of start working the braid toward the underside. And the more slack you can get into it, the better off you'll be. Because you have to maintain the ground. You don't just cut it off. I'm not cutting it off. I've just loosened the braid up. Okay, see it looped underneath? I have not cut it off as I did for the end. Okay. I have not cut it off. It's just a little difficult to work with, but it's workable. Yeah.
That's awesome, so that you can connect the cabling all together?
Yes.
Ah,
Maintaining the ground
right.
and the 2 hots.
So if you've got a flat roof and you've got your gutters all the way around, north, south, east, and west, you just connect those cables one to another?
Yeah.
And down to the
Yeah,
ground wire?
you can do that depending on the length.
Right.
Always maintain. Again, you'll see chart lengths here on what they recommend. I will tell you I've gone over it a little bit and had no problem. But mainly I follow their recommendations.
And how do you, after you've got it all connected to the flat roof, how do you connect it from the garage roof to another? Do you supply another lead? Another
Well, you
electric
may have
box,
to run two separate
GSM
systems.
two
If in
separate
fact the gutters you're heating are far apart,
right.
you may just run two systems, that's all.
I see. Thank you.
Okay, getting there. Ta-da-da. This blue you see here is another protective layer, by the way. So now that we're done with the ground, we take it, and what they just recommend is twisting it into a workable wire. By the way, you want to be careful, especially working with this stuff with bare hands. It can be extremely sharp, and if you get a lot of little frayed ends, it will cut into your skin. So just a little warning there, because I've done it and I've had to pull out little pieces of stainless steel out of my fingers. Now the only reason I have a couple pieces left is because of my job on Monday afternoon, but this is supplied in the kit much longer. All it is shrink tubing. You notice it's green and yellow, which is more of the international ground colors as opposed to United States pure green, but it gets the message across that this is in fact a ground wire. That gets slipped over the ground. I could use a cigarette lighter. Sometimes these work a lot faster. Just a little mini torch. You could use a big torch too, but that's kind of overkill on this stuff. Yeah. Now, like I said, this is a short piece. Normally, it would extend almost all the way. This does protect the ground because it can fray a little bit because of the weave. So this holds the ground all together without it fraying. And that's the ground. All right, now that we...
How careful do you have to be about the rest of the sheathing while you're shrink wrapping it?
Well, you don't want to burn anything. That's why I use a mini torch as opposed to a big one. I could, just as well, do that, and it would work.
But you can get pretty close.
Yeah.
Okay.
But again, if you start to see it char, you want to pull back immediately. You don't want to burn this stuff. All right. Now, to get rid of the rest of this. Again, we're going to start maybe a ½ inch or so down from this sheathing. They say about an inch. and just cut right through the center of it. And then you're going to want to peel that back too. Inner is a lot tougher than the outer, by the way. So in effect, your cable is protected by three, the heating element on this cable is protected by three things. The outer waterproof cover, the stainless steel braid, obviously, and then this tough inner cover. And this is your heating element now. This is self-regulating along its total length. By that I mean if, in fact, for whatever our configuration, we had cables stacked together or cables crossing, okay, normally you would think, especially with the easy heat stuff, that would cause a hot spot. Here, this is going to sense that hot spot. And in that little spot, it's going to run cooler. Okay, remember I said about cold and hot regulating this stuff? It's through the whole length of the cable. Okay? So, in fact, if I had to cross cables, it's not going to create a hot spot. All right? This little area here on both cables will sense that extra heat, and in that one spot, run just a little cooler. We're not conducting the length like this. We're conducting across the two wires, the whole length. All right, so this conducting thermoplastic, you're not depending upon heat going this way. It's going this way between your hot and your neutral, or in the case of 240 wire, between the two hots. So it conducts across each other. So that's how it can sense that. And then we just sort of try and cut out a little bit. And peel it back. Now I've exposed one of the wires. And again, what they do, they give you shrink tubing. Again, in the package, it's much longer. These were just cut-offs from the other day. Then you bring the shrink tubing, and again, they've got this separation. Your ground way up here, and then your hot and your neutral, or your two hots, essentially about an inch away. Just so you don't, again, short the wire out. And again, all it is shrink tubing. You notice the wire is like a silver coated. That again is for corrosion resistance. It's not an extremely heavy wire. This is getting back to you, this is why they want to limit the length in case the amperage starts going, and you can run 30 amps. But they definitely want to limit the length. Okay. And again, normally I'd have 2 leads like this. The other one's just sitting in here still. And the one piece I don't have is, you look at your sheet, there's a much wider piece that's only about that long. At that point, that gets slipped over here and all the way up to the braid, all right? And then that gets heated up, again, whether you use a torch, a bigger torch, or a lighter of some sort. And the final application is that as it's heating up, you'll see, in effect, a sealing gel coming out of it, okay? All you're going to end up doing is taking a needle nose pliers, then, and right between the 2 conductors, you're going to pinch it and hold it again for about 10 or 15 seconds. And what in effect that does is take the 2 conductors and totally insulates them and away from the ground. So this thing is totally sealed at that point. Now, if I was connecting 2 cables together, there would be a third shrink tubing, again, even heavier. If I was connecting here to the wires, obviously my hot, neutral, and ground all get connected together, and then another piece of tubing goes over that connection and gets shrunk on. And again, as this stuff heats up, you'll actually see gel come out of the ends of this. So it's not only shrink tubing, but there's a sealing gel inside of that as it heats up, expands and then freezes. So, I can go right into a box with this, or I can connect 2 or 3 cables together, or connect it to a plug. Either way right now, I can't go any further because I don't have the rest of the parts, but that gives you an idea how it is to work with. Didn't take me that long. You just have to be careful as you're cutting. Be careful about the stray braid. You don't want that getting near the conductors. Use the shrink tubing where you have to, and you'll be fine. It's not hard to work with. The same thing with your pipe heating cables. All I'm doing at that point is, again, taking the covering off, exposing the conductors, doing the same thing, except then I'm saving this, all right? So I can take that ground and literally put it to the ground screw, and then where the 2 wires come in, up into the box, and run my connections. Okay, do you need a box on your pipe? No, you don't. The box can be elsewhere. They just give you the bracketry to do it. Not necessary, okay? But, keeps it neat. You notice they're using they recommend and show in the diagrams an outdoor box. Why? Simply because it's near water. Even though it's in a pipe, there could be a downspout somewhere, so they're just, they recommend an outdoor box, that's all. Are there other ways to get into a gutter besides feeding down and or up, by the way? You don't have to feed down, you can feed up. So if you're going through the wall, let's say, of a basement near where the gutter gets into the ground, where the downspout gets into the ground, there are ways to feed into a gutter and go up. Highly unusual, but effective. Okay, I'm feeding direct into the gutter. And now I can go up the downspout and lay it into the gutter system and or across the roof and whatever, all right? And I am, in effect, grounded. Easy thing about this is I've grounded the electric box. The electric box is, in fact, attached to the gutter system. It's grounded. You don't have to run a separate ground anywhere. This is not easy, by the way. I think working with the cable is a little difficult. Getting into a gutter system from lower on, normally you have to cut out a small section. And remember, you're going to want to feed into the ground, not just to the ground. You want to get about 4 feet into the ground where that end is on here, okay? 4 feet because that's where the thermocline in Chicago is, where the ground won't freeze down that far. If you just get to the gutter end where it's, you know, going into the drainage system, that could freeze right there, and then your whole thing is going to, you know, freeze up too. Normally it wouldn't happen with gutter cables, you know, because the water will be slightly warm going through, but just to make sure. And what they recommend also is that while you've got that end on here, okay, you don't want to feed that end into the ground directly. They recommend that you do this to the cable, okay, so that end, the solid part of the end is facing up as this feeds down into the ground.
You got this 30 feet down and you got it looped over. What keeps water from going inside that little part when the downspout's coming down?
Well, remember, the end now,
You use
in
the
your
block,
diagram,
you use this block
yeah, that's the end.
for all the
It
downspouts.
is now facing up.
The downspouts. Okay.
It is now facing up the downspout. This is going down into the ground like this.
Right, the downspout. Now you flip it, it's up like that, then this block
Right.
seals it off.
Yeah.
Thank you.
The only reason 15 years ago, they didn't have that recommendation, okay? I was putting the ends directly down into the ground. Since then, they've modified that, and now they recommend that the end face upwards. Probably because of a mechanical, could that end somehow be knocked off if ice kept hitting it and, you know, kept hitting that gel if it was face down? Okay, so they recommend now that that end face up, and the easy way to maintain that, obviously, is just a wire tie. You know, now I've got the end here facing up. I've got a gentle loop facing down, so it'll easily feed down the downspout and then into the ground. Remember, my downspouts were 27 feet, so I measured 31 feet. I was feeding down. Okay, when I marked it off with tape, when I saw that tape mark, I knew I was 4 feet into the ground.
Oh, quick question. If we have the downspout leading into a catch basin, and then there's like another 4 feet after the tube goes into the catch basin, does
You
it
should
still
be
have to go-
fine going into the catch basin.
Okay.
Just let that end free float into the catch basin. In fact, if you just see it right at the where this would come right at the catch basin, you're probably good right there. The catch basin is not going to freeze over.
Okay.
So if you can see the end of the pipe, just right at the catch basin, that's where you can stop. If you wanted to go a little bit into the catch basin, it's not going to hurt. But if somebody has to pull maintenance into that catch basin, like getting the sand out or whatever, then they keep hitting the cable. So that's why I don't recommend it looping into the catch basin. Just keep it right at the end of that pipe where you can see it, and then you'll be fine.
Okay. Cool. Thanks.
Unless there's any questions.
Is there any way to test existing cables to see if they're still working?
You could, sure. Number one, if the cable was shorted out, You'd know that instantly when you turn the breaker on and or the GFI, because it would pop right there.
Priority is very up front.
Number two, obviously on a cold day, if you can get to the cable and just put your hand on it, you'll feel the warmth of the cable. And number three, if in fact you had, and again, remember this stuff is self-regulating, so it's not really gonna help on a 90-degree day testing it, okay? You're gonna wanna get there, 40 degrees or whatever. And if you have, in fact, a clamp meter of some sort to be able to read the amperage, then you're gonna, encircle the hot wire that feeds this cable and make sure it's drawing amperage, in fact, working. But again, you won't be able to do that unless the cable's cold. Disadvantage, but so sure, there's ways to test it. Easiest way is, just hold it on a cold day and it should be fine. The other cables, the Easy Heat, again, they don't self-regulate, so they're easier to test. Just grab and you plug it in and grab it, and you should be able to feel the warmth on it. These, because they are self-regulating, they have to be cold in order to test them. Any other questions? Yeah.
One more question. I don't think I'm going to be able to do this myself. Is there who could we hire to do that? Would that be an electrician or a roofer?
Most roofers or gutter people that I know of don't work with this stuff. So you're probably looking at a very knowledgeable handyman and or an electrician. Yes.
Okay.
Most of the people I know that deal with it are in fact electricians or handymen that know quite a bit about electric.
Okay.
And know the codes and so on and so forth. Yeah, but I know a number of gutter people and roofer people, and they stay away from it for whatever reason, just because it's not not what they do.
Well, I'm installing 300 feet, and the first 200 feet I ran down, and it works perfectly on a circuit breaker. But now that I look at the self-regulating, because of the footage and the wattage, I have to come with another breaker to take the other 100. That's keeping on the safe side.
That's their recommendation.
Right.
I've gone maybe 10% over, and I've had no problem. But I don't press it. I follow their recommendations.
Right. To try and save the cable for the years coming. So
right.
Every year it works.
Maybe if you press it too much longer than that, you're stressing the cable.
Right.
Possibly.
True.
Again, these conductors are not that heavy. This I would think this is equivalent to 14 gauge. Okay, and they're even putting 30 amp through it, to get to 150 feet. They say this is 6 watts per foot. Obviously, that may be a minimum.
E times
If
I. E times I gives you the voltage.
So, it might draw, once it starts getting extremely cold, it could be drawing more than 6 watts.
Right.
And I think that's where their recommendations come in, to limit length.
Well, I'm looping it closer together to keep the ice buildup.
Well,
that's the problem.
If you're looping close together, you're going to eat up more cable.
Right.
Obviously.
That's why the other extra 100 feet came in.
Right.
Thank you, Austin.